Greetings to everyone. My name is Ying, and this is the demo video for my final year project, which the topic is frequency reconfigurable antenna for health monitoring application. And in this video, I'm going to show you the antenna design and demonstrate a simulation result in CST Studio. First of all, let me show you the geometry of the original Meander Bowtie antenna, and the dimension of the antenna is 33.4 mm times 11 mm. The antenna is resonant at 2.45 GHz, and the radiation pattern of the antenna is omnidirectional. Next, this is the finalized design of the antenna. We use re-switch as the switching method to tune to 2.3 GHz and 3.5 GHz. And to achieve a lower frequency band of 2.3 GHz, we add symmetrical patch at the end of the arm or antenna to increase the electrical length of the antenna. And to achieve the 3.5 GHz frequency band, two symmetrical slots are inserted into the antenna design to carve off the arm of the antenna so that the electrical length of the antenna can be decreased. Then we implement the re-switches at each end of the antenna. This is the simulation result of the frequency reconfigurable antenna. For the first case, when the re-switch is switched on, the antenna is operated at 2.3 GHz. And for the second case, when the re-switch is off and the antenna is operated at 3.5 GHz. For the first case, when the re-switch is on, the current distribution is distributed evenly until the end of the arm of antenna. And for the second case, when the re-switch is off, we can see that the current is only concentrated at the middle of the Bowtie antenna, and we can actually see that the current is open at the slot that we inserted into the antenna. For the radiation pattern, it remains omnidirectional for 2.3 GHz, and also for 3.5 GHz it remains omnidirectional radiation pattern. For the result analysis, we will see the effect of variation of size of the additional pages. The size of the additional pages is vary from 0.4 mm to 5.4 mm, and the results show that when the page size increase from 0.4 to 6.4, the resonant frequency shifted to the right, which means that when the patch size of the additional patch increase, the electrical length of the overall antenna is increased, so that the wavelength of the antenna will become longer and the frequency of the antenna will become lower. Then I replace the re-switches with the copper slip. This is to test the validity of replacing the re-switches with copper slip so that it can be used in fabrication. Also, I shorted the additional pages to the end of the arm or antenna, as in this project we only require the 2.3 GHz and 3.5 GHz frequency band. As a result, the antenna can be operated at 2.325 GHz when the copper slip is connected, and 3.5 GHz when the copper slip is removed. The results show a good agreement with the design specification and also validate the use of copper slip to model re-switches in fabrication. Lastly, for the antenna on body testing and SAR analysis, I constructed a human chase model which made out of 3 layers, which are the skin, fat and muscle. The antenna is placed on top of the human trace model, and the distance is vary from 2 mm, 5 mm to 10 mm. As a result, we can see that when the antenna is placed closer to the human trace model, the frequency shift further to the left. The human trace model is cut into half and see the SAR inside body penetration rate. And obviously we can see that the maximum SAR is concentrated at the surface of the human trace model, and it will be attenuated when you go further inside the human trace. So this is the summary result of the SAR analysis, and from the result we can see that the effect of distance and reference power on SAR tangram. The reference power is vary from 25 milliwatt to 200 milliwatt, and as you can see, when the reference power increase, the maximum SAR will be increased, and as the spacing between the antenna and human body increase, the SAR is decreasing. So for the SAR tangram to be kept under the IC SAR standard of 2 watt per kilogram, we suggest that the reference power of the antenna must be kept under 50 milliwatt. I think that's all for my demo video. So further information will be present during the seminar.